In this lesson, we'll continue big ideas number 1 and 2. So, what are organic compounds and how are they classified? How does the structure of an organic compound determine its physical and chemical properties? We're going to do that by continuing learning target number 1, and we're going to learn about alkenes, alkynes, cyclical, and aromatic organic compounds. Alkenes are aliphatic hydrocarbons with double bonds as their functional groups. Since each carbon is not bonded to the maximum number of atoms, alkenes are described as being unsaturated compounds. So alkenes have the general formula CnH2n if the alkene has a single double bond. Whenever you put a double bond on a hydrocarbon, you have to remove 2 hydrogen atoms. So, naming alkenes. You'd follow the alkane rules, and you would use the suffix "ene" to indicate that it's an alkene family. Double bonds must be included in the main chain, and they take numbering priority over alkyl groups. That means that double bonds always have to have the lowest number. You would add the position number to tell me where the double bond is in front of the suffix if there is more than one possible location. If there is more than one double bond, you list all the position numbers and then place a molecular prefix in front of the ene. So, here are some examples. If I'm looking at A, my main chain is right there, longest consecutive chain of carbons. So because I have 4 carbons, my root is going to be a bute, and because of the double bond that's here, I'm going to use "ene" as my suffix. Now, with 4 carbons, there's more than one place where I can put the double bond, so I have to provide a position number. If I number my carbons 1, 2, 3, 4, then I have a double bond between carbon number 2 and 3. If I number it from this side, it's still going to give me 2 and 3 as my position number. Now, to indicate where the double bond is, you put the lowest of those 2 numbers, so 2. That indicates that it's between 2 and 3. And then "ene." So this is bute 2-ene. For the next example, B, my longest chain is going to be the carbons going straight across the page. 6, so that gives me the root hex. And I have a double bond, so it's going to be a hexene. Now I got to figure out where that double bond is. If I number from this direction, my double bond is going to get a lower number. So it's going to be a hex 2-ene. Now I also need to include these 2 groups in my prefix. So I'm going to have, there are methyl groups. I have 2 of them, so I put a di in front, and position number, they are both on carbon number 5. So B is 5,5-dimethyl hex 2-ene. Pause the video now and generate the name for example C. Here's the answer. My main chain goes like this. Longest consecutive chain of carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gives me a root of known. Now I have 3 double bonds. I have to number them so they get the lowest position number. That would be if I start from this end. So So I have double bonds on carbon 2, on carbon 4, and on carbon 6. And because I have 3 of them, I put tri in front of the ene. Now, I also have to include that and that side chain. I have a methyl group and an ethyl group. They need to be listed in alphabetical order. So, methyl comes second. It's on carbon number 4. And my ethyl is on carbon number 6. Sorry, I got a little messy there. So the answer is 6-ethyl 4-methyl known 2,4,6 triene. Properties of alkenes. If you compare an alkene and an alkane with the same number of carbons, the alkene has a smaller structure because for every double bond you add, you have to take off 2 hydrogens. So this will have alkenes having a lower melting point than alkanes. Because of weaker London dispersion forces due to the smaller size. Now, alkenes are nonpolar. That means that water can only use a weak dipole-induced dipole in order to dissolve them. Therefore, alkenes have a low solubility. Other things you need to know about alkenes. Small alkenes are used as fuel, and they are heavily used as starting ingredients for making different kinds of plastics. Because of that double bond there, it gives you more options of reactions that you can do with alkenes over alkanes. Alkynes are aliphatic hydrocarbons with triple bond functional groups. Alkynes are also described as being unsaturated compounds. Alkynes have the general formula CnH2n-2. The reason being, for every triple bond that you add to an alkane, you have to remove 4 hydrogens. To name an alkyne, you follow the alkane rules, and you use the suffix -ine, Y-N-E. Triple bonds have to be included in the main chain, and they take numbering priority, which means they always get the lowest number, as opposed to other side chain groups. You need to add a position number for the triple bond in front of the suffix if there's more than one possible location for that triple bond to be on the molecule. If there's more than one triple bond, list all the position numbers and use a molecular prefix in front of the -ine. So here are some examples. For A, my main chain is 4 carbons going horizontally across my page, and I have a triple bond there. Because I have 4 carbons in my parent chain, my root is going to be bute, and I need to number my chain so that that triple bond gets the lowest number. If I do that starting on the right side, I'll have my triple bond at carbon number 1. So example A is bute-1-ine. For example B, my main chain is also 4 carbons, going horizontally across. I have a triple bond, and I have a methyl group on my molecule. I need to number my carbons so that the triple bond gets the lowest number. Because I have 4 carbons in my main chain, that's a bute. I have a triple bond on carbon number 1, and I have a methyl group on carbon number 3. So 3 methyl bute 1 ine. Pause the video and write the name for molecule C. Here's the answer for molecule C. My main chain is 8 carbons going horizontally across my page. I also have a triple bond here and here, and I'm going to end up with 3 methyl groups left to describe. Because my main chain is 8 carbons, my root is going to be an oct. Now, I need to number my main chain so that my triple bonds get the lowest possible value. I achieve that by starting on the left side. So I'm going to have a triple bond on carbon number 2 and on carbon number 4. And because I have 2 triple bonds, this is going to be a di-ine. Now for my prefix, I have 3 methyl groups. Because I have 3 of them, I stick the prefix tri in front, and for position numbers, they're going to be on 6, 6, and 7. So I have 6, 6, 7 trimethyl oct 2,4-di-ine. Properties of alkynes. Whenever you have a triple bond, that introduces a more linear shape. So alkynes will stack better than alkanes. Therefore, alkynes have higher melting points than alkanes. In terms of solubility in water, a triple bond does not affect the polarity, so it is still nonpolar. Therefore, water can only use weak dipole-induced dipole attractions. Therefore, alkynes have a low solubility. Other information about alkynes: they are often used as starting materials for building other molecules in industry and then also in medicine.